It's your friendly math tutor, Miss C here, and today we are sketching the graph of a quadratic function and describing its end behavior. So when we're sketching, we are estimating a lot of points, but we are plotting some of the points accurately. So the 3 points that we are going to plot accurately are the y-intercept. We're going to plot the roots or the x-intercepts. Sometimes those are called zeros. And we're going to plot the vertex. And then we're going to have the general shape. We know the general shape of a quadratic function is a parabola. So it's either an right side up U or an upside down U. And then we'll have our graph go through these 3 points. So I always like to start with the y-intercept because it's the easiest thing to see. It's also the easiest to calculate. So essentially, the y-intercept happens when x takes on the value of 0. And you're going to notice that I have an x term here and an x term here. When both of those are made to equal 0, all that's left is my c term. So remember, the coefficient in front of x squared is a. So in this case, it's 1. The coefficient in front of x is b. So it's -4. And then this 3 is the c term. So my y-intercept here, when I plug 0 in for x, it's 3. If you want to see that algebraically, look what happens. We end up with y equals 3 when we plug 0 in for x. So that's why that one works. So that's my first one that I like to start with because you actually don't have to calculate it at all. You can look at the c term. All right, our roots and our x-intercepts can be found by a couple of different ways. You could use the quadratic formula or you could factor. I'm looking at these numbers. These numbers look pretty easy to factor. So I'm going to go ahead and set up my factored form here. I'm looking for 2 numbers that multiply to +3 and add to -4. So because I've got a positive here and a negative here, I know that the only way to make a positive here and to get a negative here is to multiply, is to have both of these be negative. So 2 negatives make a positive, but when you sum 2 negatives, you get a negative. So the factors of 3, well, 3 is prime, so it's 3 and 1, or you could say x minus 1 times x plus 3. So let's just do a quick check. If we were to distribute this out, I would have x times x, which is x squared, x times -1, which is -1x, x times -3, which is -3x, and then -3 times -1, which is +3. Look at that. That is -4x, +3. These are the same exact, these are the exact same equations. They're just written differently, right? Because if I expanded this out, I'd get the same, what I started with. So now we need to figure out what our x-intercepts are. So x-intercepts happen when y is 0. So if I rewrite this such that y is equal to 0, okay, what I know is that if I put 0, if I want one of these to become 0, like for instance, if this binomial equals 0, 0 times the other binomial is 0. So what does x have to take on to make this 0? X has to be 3. So when x is equal to 3, I have 0 times this, which is 0. Or x could be, what makes this binomial 0? It's 1. If this x was 1, 1 minus 1 is 0. 0 times anything is 0. So that makes this true. So our 2 roots are 3, 0 and 1, 0. All right. I'm going to erase this and we will find our vertex. So let's now find the vertex. So like many things in math, there are lots of ways to find the vertex, including a method called completing the square. But I'm going to use a quick rule or formula that's going to help me find the x-coordinate of my vertex and also the equation of the line of symmetry, because a parabola is symmetrical. And then we can find the y-intercept. So the rule that I like to follow is x equals negative b over 2a. And this will help us find the x-coordinate of our vertex. Okay, and the equation for the line of symmetry. Okay, so we know that whatever's in front of x squared is our a term. So in this case, a is 1. We know that what is in front of our x term is b. So b is -4. And we don't need c, but we know it's 3. So I'll just say c is 3. Okay, so all I'm going to do at this point is I'm going to substitute. So everywhere I see b, I'm putting in -4. So my negative is here. So I'm going to plug in -4 all over 2 times a, and a is 1. So you can see those substitutions. So my x equals -4, which is +4, divided by 2 times 1, which is 2. So x equals 2. So the x coordinate of my vertex is 2. I'm also just going to say that my line of symmetry, which we often abbreviate as LOS, is equal to 2. So this is that invisible line from which all of our points are equidistant in our parabola. All right, now to find y, we are going to just plug 2 in everywhere we see x in our equation. So I'm setting us up to plug 2 in. There we go. So I'm going to go ahead and plug 2 in all of these places. So y equals 2 squared, which is 4, minus 4 times 2, which is 8, plus 3. So y equals 4 minus 8, which is -4, plus 3, which is -1. So when x is 2, y equals -1, which means that our vertex has a y coordinate of -1. Okay, so the great news now is that we are ready to graph. So let me get some graph paper up and we'll do. All right, so we are ready to sketch our graph. So I put up some graph paper. So I'm going to go ahead and draw my axes here. Oops. Maybe I'll draw my axes straight. We'll see how this goes. Here we go. So this is going to be my y-axis, a little crooked. And my x really crooked. Oh my goodness. Let's try that one more time. I clearly should have pre-drawn my lines. So we'll say y and x here. All right, so I'm just going to plot what I know. We're going to go by ones here. Okay, so 0, 3. So that's my y-intercept is right here. My roots are 3, 0 and 1, 0. Okay, and my vertex is my lowest point on the graph. I know it's the lowest point because this is positive. A is positive right here. So 2, -1. Okay, and I'm going to just sketch in my line of symmetry. You don't have to do this, but it's this little line here. So what you're going to notice is every point is equidistant from it. So if this is 1 unit from this, right? If this is 1 unit, this one will be 1 unit. So I could plot one other point if I wanted to. So if this is 2 units, we'd have another point 2 units away. All right, so I'm going to go ahead and sketch my parabola. It makes a gentle U shape. Okay, arrows on both ends because it goes on infinitely. So if I were to describe the function's behavior, put a parenthesis there, what I could talk about is all these points and the line of symmetry that I know. I would also say as x decreases, so basically as we're reading the graph going this way, so as x gets smaller, y increases, it continues getting bigger. And if we look at it this way, as x increases, so as x values are getting bigger, y continues to increase. So sometimes we call this end behavior. So if a problem ever asks you to describe the end behavior of the graph, these two statements would do just that. So if I were writing a comprehensive response, like if I had to do this on a test, I would say this parabola or this quadratic function has a y-intercept at 0, 3. The vertex is the lowest point, and that occurs at 2, -1. My parabola that is upward facing passes through the roots 3, 0 and 1, 0. And as x decreases, y increases. And as x increases, y also increases. We've described the function's behaviors. All right, if you found this video helpful, please like it so it shows up for other folks. Make sure to subscribe so you don't miss any content. Until next time, remember, you've got